Hello. In my previous videos, we tried to create a simple multi-threading Java game with monitor pattern. In part 1, we represented the enemy locations in a hash map and use a thread-safe monitor to control the access. In part 2, we update the enemy tank locations with another thread. We also allow the enemy tank to kill our tank. The program we left over from last time suffered multi-threading issue. Sometimes the first shot does not display correctly. Before we jump into fixing the problem, let's first analyze from the perspective of multi-threading. Let's ask these questions. How many threads are involved? Is there any variables that form the GameBoard's state? Is there any invariants that constrain the state variables? Are all swing component methods invoked from the event dispatch thread? Are these methods labeled thread-safe in the API specification? Remember, in the absence of synchronization, the compiler, processor, and runtime can do downward write things to the order in which operations appear to execute. Attempts to reason about the order in which memory actions must happen in insufficiently synchronized multi-threaded programs will almost certainly be incorrect. So let's copy the code and put it into Eclipse. I already did so. First question, how many threads are involved? The answer is 3. We have main thread. We have updater thread, which animates the enemy tank. Thirdly, we have the swing event dispatch thread. See all those override methods. Those codes are executed from the swing event dispatching thread. Totally, we have 3. Next question, how many state variables belong to the game board? We don't need to worry about the public static final fields. Those are thread safe. We have 5 state variables: dx, dy, yourtank, laserBeam, and monitor vehicle tracker. What are the constraints posed upon those state variables? dx, dy need to be updated atomically. You cannot have them updated separately, otherwise your tank will show in a position it has never been. Okay, dx, dy is invoked from the main thread. Right, this code is executed from the main thread. When you initialize the game board, the main thread executed this code. dx, dy is also executed from the event dispatching thread. You see here, move rec and shoot. They are executed from the event dispatching thread. So there are 2 threads, updates dx, dy without correct synchronization. So that is the first problem we need to fix. Currently, dx, dy's invariant is not preserved correctly. Next, yourtank and laserBeam. They are also shared among multiple threads. Here the main thread is executing this line and this line. And yourtank and laserBeam is also referenced in the event dispatching thread in this code. So again, we saw 2 threads are sharing state variable without correct synchronization. Which we need to fix. what problem could happen is, you see the GameBoard is initialized in the main thread. When a reference of GameBoard is returned to the paint panel, the paint panel may not completely initialized. You could get a partially initialized GameBoard object. yourtank and laserBeam could just get a default value, which is null. That's one of the better scenario. And before the paint panel is fully initialized, it is used in the updater thread. When the updater thread trying to do the repaint, it is screwed because your paint panel haven't been initialized correctly, haven't been initialized completely. It is only happened in the matter of nanoseconds, microseconds. That's why the first time you saw the problem, it didn't happen in the next play. Because the next gameplay, the JVM already cached your object, so you don't need to allocate the resources. And the next time it's faster, you didn't see the problem anymore. Those are the machine details. If we are trying to analyze, it's hard, but what we can do is we can make the program correct. We don't need to worry about the machine details. The monitor vehicle tracker. This object is thread safe, as we analyzed before. It's all the public methods are correctly synchronized, so it can be shared among multiple threads without worrying about synchronization issue. You see, when we do the construction, we do deep copy, and when we try to get location, we do deep copy. We make new object when we try to get location. We get the location and change the value. So all the public methods are thread safe. We don't need to worry about synchronization. Finally, is all the swing. Are all swing component methods invoked from the event dispatching thread? Are these methods labeled thread safe in API specification? Okay, in our code, the answer is no. This repaint is not called from the event dispatching thread because it's in the updater thread. Okay, let's go to check the document. Document didn't say this method is thread safe. But if we keep digging in the implementation of repaint, if it's a lightweight pair, you call itself. Otherwise, you submit an event to the event dispatching thread. So the implementation tells us, even though it is called from a thread outside of its event dispatching thread, but finally the effect is submit a paint event to the event dispatching thread. So this method is thread safe, even though the document didn't make it clear. Okay, we have finished analyzing the problematic code. In the next section, we'll be trying to fix it. Let's check. Is there?